Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at the guided notes called Compare Populations, Analyze Graphs. Alright, so let's do a review. Measures of center. The measures of center we've talked about in statistics are the mean, the median, and the mode. Their purpose is to describe the center of the data, which is why they're called measures of center. Now, measures of variation. These are going to be your interquartile range or your mean absolute deviation. The purpose for measures of variation is to describe the distribution, or also known as the spread, of the data. In other words, how spread out is our data. Now, I should note that the range is also technically a very basic measure of variation, but it's not the main one that we normally use. Normally we use interquartile range or mean absolute deviation as our measure of variation. Now, there's some more vocabulary you should be familiar with. The phrase more variability can be used when one set of data is more spread out than the other set of data. The phrase more consistent means having less variability, which means being less spread out. Now, quick summary. If your measure of center is the mean, then you're going to use the mean absolute deviation as your measure of variation. However, if your measure of center is the median, which by the way, box plots, that's the way it's always going to be, then the interquartile range will be your measure of variation. All right, some more vocabulary. The word inferences, you're going to hear that word a lot on these guided notes. That means conclusions or predictions based on analyzing data. And the graphs that can be used to compare two populations, and when I say two populations, I'm talking about two sets of similar data. The graphs that we're going to be looking at today are going to be double box plots and double dot plots. Now, we could also use double line plots, which look very similar to double dot plots, except they use X's instead of dots. You actually see that on one of the pages near the end of these guided notes. So, quick review on box plots and also on dot plots. Box plots, remember how the dot somewhere inside of the box is not always at the exact middle, but that dot inside will be the median of all the data. The symbol for median of all the data is called Q2. You probably remember that from earlier other guided notes that I've taught you. And to get the interquartile range, we will take Q3 minus Q1. Well, that's basically just the left edge and the right edge of the box, subtract those values. Now, there will be numbers under the number line. This is just a generic example I've given you here. But subtract the Q3 and the Q1, that'll give you the IQR. Basically, how wide the box is going to give you your interquartile range. The last thing I want to remind you of, each section of the graph for a box plot represents 25% of the data, which is where the word quartile even comes from, or it gets used when we're talking about the calculations that make the box plot or the box and whisker plot. So from the lowest value up to Q1, that's 25% of the data. From Q1 to Q2, that's 25% of the data. From Q2 to Q3 is the next 25%. And finally, from Q3 up to the highest value is the last 25% of the data. Now, dot plots. Obviously, you need to count the dots in order to know where your median is going to be. You can also use the dots to get the mean. Sometimes we'll use the mean, sometimes we'll use the median. It all kind of depends on what data you're looking at. One thing we've never really talked about before, but I want to talk about it here, is symmetric data. Symmetric means, well, you can kind of see. It's like a mirror image from the middle to the left, from the middle to the right. So that's what symmetric data looks like. And if the data is symmetric, like you see here, it's actually going to be super easy to see what the median is just by looking at the dots. And also, whenever you have symmetric data, the mean will be the exact same value as the median. Now, if the data is not symmetric, then the median or the mean might not be as obvious to find without actually doing the math work. So let me show you exactly what I mean here. Let's pretend we didn't realize that symmetric data basically gives you the median just by looking at the middle of those dots. Let's do it the old-fashioned way just to prove my point here. Let's count the amount of dots. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And if we take 13 divided by 2, because remember the median splits the data into two equal halves, we get 6.5. Now, there is no such thing as a 6.5th number. So, as I've taught you before, round up. That means the median will be the 7th dot. So, let's count. 1, 2, 3, 4, 5, 6, 7. This dot right here is our median, and obviously that dot is at the value of 17. So that's our median. Now, for the mean, sorry, I forgot where I had that. The mean, this is going to be a little bit trickier. We know there's 114, but we know there's 215, so 2 times 15 is 30. We know there's 2 16s, so 16 times 2 is 32. You don't believe me, you can use your calculator to help keep up here. There's 3 dots at 17. 17 times 3, you can use your calculator if you need to, is 51. 2 dots at 18, so that's going to be 36, because 2 times 18 is 36. And then 2 dots at 19, 2 times 19 is 38. 1 dot at 20. Add all these together. I'll go ahead and do it for you. You could use your calculator if you wanted to. I'll give you 221. What are we dividing by? Oh, that's right. There was 13 dots. So we're going to divide by 13. Go ahead and do this in your calculator along with me. 221 divided by 13 is 17. But remember, I already told you, if the data is symmetric, like this one, then the median and the mean, they're going to have the exact same value. And let's be honest, couldn't you tell that the center of the data was here at the 17? You have the same pattern of dots to the left as you do to the right of that 17 place. So this is what I mean. When the data is symmetric, it's really easy to see what the median is going to be, and the mean's also going to be the same as the median. Now, that's only true when the data is symmetric. If it's not symmetric, then you're going to definitely have to do the type of math work that we were doing here. All right, next page. Here's the big thing we're going to be doing today. Analyzing these graphs. And here's what you need to do for multiple choice problems. You got to ask yourself, what are we given? And in order to know what we're given, we're going to read the sentence, or maybe sentences, might be more than one, that are explaining the situation that the graph represents. We're going to definitely read the title, if there is a title, and we're going to read the labels. That's obviously very important. Now, other basics things you should be asking yourself. What does the problem want us to find? What are we asked to find? Does it want us to know what's true? Or is it asking what's not true? That's really important that you read the question that the problem's wanting you to find. And we are going to test each answer out. Now, this is very different from most multiple choice in math. Most of the time in math, you guys know how it works. You figure out the problem on scratch paper, then you find the answer that matches your answer. But as you're going to see on today's guided notes, these are analyzing graphs problems. They're going to give you 4 different inferences, meaning 4 different conclusions. And we have to figure out which one of those conclusions are true, or for some questions, which ones are not true. So we are going to test each answer choice to see if it's true or if it's not. And we might need to do some math work from time to time. So when it's needed, we will do the math work. And by the way, if it helps to write things on the graphs or next to the multiple choice answers, then we're going to do whatever it takes. We're going to write down whatever we need to write down to help us figure these out. All right, I'm going to do the first few of these with you to kind of give you the feel of this, and then you'll do kind of like the last half on your own. So let's check out number 1. It says the double box plot shows the heights in feet of roller coasters from 2 amusement parks. Now, I made these 2 parks up. I don't really think these are real parks. I just made them up. We got Crazy Thrills Park. We got Coaster Mania. So we always got to look at the labels. We have to read the sentence to know what we're talking about. So these are heights in feet. You can go ahead and underline that if you want. I'm going to highlight it. Heights in feet of roller coasters. All right, forgive me for not being able to highlight straight across. Now, the problem says, and I would underline this, which statement is true? Okay, so this is not one of these tricky which one is not true situation problems. This one wants to know which of the following is true. All right. The first one says 50% of the roller coasters at Crazy Thrills Park, so that's the first graph on top, are 150 feet or more. All right, I'm going to use my highlighter You should not use your highlighter as you do this because you're going to be highlighting way too much. I'm just going to do this so you know exactly what I'm looking at here on my screen. 150 or more. Here's the 150 dot, you can see. And if I go 150 or more, what percent of the data is that? Well, that's from Q3 to the highest dot. That's only 25%. So goodbye, choice A. They said 50%. Well, that's not correct. All right, next. It says 75% for choice B of the roller coaster's heights at Coaster Mania. Okay, that's the second graph. Are 100 feet or less. All right, 100 feet or less. Here's 100 feet. Now notice I'm on Coaster Mania. That's what this talked about. 100 feet or less. That's two sections of 25%. Because from the lowest value up to the edge of the box, that's 25%. From the edge of the box to the dot in the middle, that's the next 25%. So that's 50%. And this is trying to say 75%. So goodbye, choice B. All right, let's go to choice C. 50% of the roller coaster's heights at Crazy Thrills Park. Okay, we're back to the top graph. Are from 90 to 150 feet. All right, 90 to 150. Here's 90. Here's 150. What percent is this? Well, that would be 50%. Oh, well, hey, that's what they said. So right now, I'm already starting to think choice C is probably correct, unless I'm misreading something. So I would recommend continuing to choice D, because if choice D ends up being right, then that means we messed up or misread something on choice C. So don't stop too early. Check out choice D. 25% of the roller coasters at Coaster Mania, okay, so that's the second graph, are from 80 to 110 feet. All right, so let's check out that section of Coaster Mania. Coaster Mania, 80 to 110. That's two sections of 25%, which would be 50%. Choice D tries to say it's only 25%, so that is not correct. So yes, it was choice C that was correct. All right, number 2, using the same data that we already saw in number 1, which of the following inferences is correct? Remember, the word inference means conclusions from looking at the data, and this wants to know which one is correct. Sorry, so it's the same kind of question that number 1 was saying, which one is true. Here it says which one is correct. Let's keep that in mind. Choice A, Coaster Mania's data has greater variability than Crazy Thrill Park's data. All right, greater variability. Remember, that's referring to a measure of variation. Greater variability means being more spread out, a bigger inner quartile range. Well, remember, the width of the box corresponds to how big your inner quartile range is. The wider the box, the bigger their inner quartile range. The smaller the box, the smaller the inner quartile range. So, does Coaster Mania have greater variability than Crazy Thrills? Well, actually, no, it's the complete opposite. The width of Coaster Mania's box is from 80 to 110. That's an inner quartile range of 30. But Crazy Thrills Park goes from 90 to 150 for the width of the box. 90 to 150. 150 minus 90, that would be 60. So that's an inner quartile range of 60. Crazy Thrills has a greater variability than Coaster Mania. Even if you just used normal range, which we don't normally use for measure variation, but even if you did, I mean, Crazy Thrills goes from 50 the whole way up to 210. So it's pretty clear to see Crazy Thrills has the greater variability. All right, so it's not choice A. We can go ahead and cross that out. What about choice B? The median height of Crazy Thrills is 1.5 times as much as the median height of Coaster Mania. All right, so the median of Coaster Mania is this dot right here. That's 100. The median of Crazy Thrills is 120. Is that 1.5 times as much? Well, you can use your calculator, although I can do this in my head. 1.5 times 100 would be 150. Well, Crazy Thrills median is only 120, so nope, choice B is not correct. What about choice C? All of Coaster Mania's roller coasters are shorter than those at Crazy Thrills Park. Well, that's obviously not true. I mean, here you got a dot at 150, and obviously there's dots there at 150. So, no, not all of them. I mean, generally speaking, Coaster Mania has lower heights than those at Crazy Thrills, but not all of them. So, goodbye, choice C. So, I'm hoping it's choice D, because if it's not, then we misread something. The interquartile range of Crazy Thrills Park's data is twice as much as the interquartile range of Coaster Mania's data. Well, it's nice that I already wrote this down on the graphs. Interquartile range of 60, interquartile range of 30. Yes, that is twice as much. 2 times 30 is 60. And this problem wasn't worded weirdly where it said, Coaster Mania was twice as much as Crazy Thrills. No, it wasn't backwards. It was actually the correct way. So choice D is correct. All right, next page. Let's look at some dot plots. Number 3, the dot plot below shows the number of touchdowns thrown by starting quarterbacks in a 12-team high school division for the 2018 and 2019 seasons. All right, you can feel free to underline the key things here so we know this is on touchdowns thrown by starting quarterbacks. We also can see it's 12 teams, so we already know there's 12 dots. If there's not, then they misled us. In fact, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so 12 dots. And it should be the same for the other one. All right, and here's 2018. That's the first graph on top. 2019 is the second one. Which of the following, here we go, is not true? Okay, this is a little trickier because unlike number 1 and 2, that wanted to know what was true or what was correct, here it's what's not true. So here's some advice. When you get a problem like this, it might actually help you to write the word true next to the 3 choices that end up being true. Because otherwise, if you're like me, your mind starts to play tricks on you and you're like, wait a minute, am I trying to find out what's true, what's not true? I don't want you to circle the wrong answer. Okay, so I'm going to actually do that as I go through each of these choices. All right, so choice A. Generally speaking, quarterbacks threw more touchdowns in 2019 than 2018. Well, that is true. I mean, look, you got all these dots except for the dot at 20. That one we also had at 2018. But all the rest of the data here for 2019 except for the 20 are greater than 20. And there was no dot greater than 20 in 2018. So yes, quarterbacks did, generally speaking, throw more touchdowns in 2019 than they did in 2018. So that one is true. That's not the answer we're looking for. Remember, we want something that's not true. So choice A is true. All right, what about choice B? All but one of 2019 starting quarterbacks threw more touchdowns than 2018. Well, actually, I just got done saying this. There was one dot that did end up being the same as some of the dots from 2018, but all the rest of them for 2019 are greater. So yes, that's all but one of 2019's starting quarterbacks. So choice B is true. Choice C, the lowest number of touchdowns thrown in 2019 is equal to the median number of touchdowns thrown in 2018. Okay, I'm going to use my highlighter. You can feel free to use your pencil and circle the lowest number of touchdowns thrown in 2019. That's the 20, okay? Is that equal to the median number of touchdowns thrown in 2018? Median, that's the middle number. There's 12 numbers. 12 divided by 2 is 6. That means the median is the 6th dot. So 1, 2, 3, 4, 5. Actually, it wouldn't be the 6th dot. It would be in between the 6th and 7th dot. But since they're the same, that's 19. So my median is 19. What did choice C say? That the lowest number of touchdowns in 2019 is equal to the median of 2000. Oh, it's not equal. The median was 19 in 2018, whereas the lowest dot in 2019 is 20. Those numbers are not equal. So, that's the one that appears to be not true. And that's what we're looking for. What is not true? So I'm thinking it's choice C. But before I move on, I am going to read choice D just to verify. The touchdown thrown by 2018's quarterbacks are more consistent, less variability than the touchdowns thrown by 2019's quarterbacks. Well, that looks to be true. I mean, these dots go from 16 to 20. That's a range of 4. Here it goes from 20 to 29. That's a range of 9. But remember, range is not what we usually use for the measure of variation. Normally we'd use interquartile range. So I'm going to do a little bit of extra work here. Even though I kind of already think that choice D is probably true just by the look of the graph, we can verify this. The median, remember, was between these two dots here that I highlighted in green. So let me go ahead and put a little borderline here, because I know then that the first 6 numbers are below that line and the rest of them are after it. So that'll help me get Q1 and Q3. So 1, 2, 3, 4, 5, 6. Half of 6 is 3. That means Q1 would be in between the third and fourth dot. Well, the third dot was 18. The fourth dot was 19. So in between, that would be 18 and a half. Now, 1, 2, 3, 4, 5, 6. So half of 6 is 3. So 1, 2, 3. So that means Q3 is in between those two dots. Well, those two dots are the same. So Q3 is going to be 20. Now, if drawing it on the dots like I am right now is way too confusing for you, you could actually list out all the numbers, 16, 17, 18, 4 different 19s, 5 different 20s. You could actually write that out on scratch paper, going left to right, and do the exact same thing that I'm doing, but here I'm doing it on the dots, and that'll give you the same values for Q1 and Q3. Interquartile range, if I subtract, is 1.5. All right, I already have a really strong feeling that the interquartile range for 2019 is going to be bigger, but let's double check. So we know 12 dots, half of 12 is 6. So 1, 2, 3, 4, 5, 6. Oh, that means the median is in between here, because we got 1, 2, 3, 4, 5. Oh, no, I was wrong. It's funny to be wrong live on video. The median is in between. Here's the 6th and 7th dot. So 6 dots to the left of it, 6 dots to the right of it. Okay, so that is my median. So my median is, well, still going to be 26. So I'll go ahead and write that down. Now, what about Q1? Well, that's going to be between the 3rd and 4th dot, because 1, 2, 3, 1, 2, 3. Yeah, so there's the halfway point. So Q1 is here, which is 24.5. Q3, let's count up again. 1, 2, 3, 4, 5, 6. So in between the 3rd and 4th, that would be Q3. So that's 27 if I subtract 2.5. So yeah, 2019 has a greater variability than 2018, which means 2018 is less variability. So yeah, choice D is true, which I kind of already suspected just by looking at the dots. So there you go. We confirmed choice C is the only one of these 4 that is not true, so that's the answer to this problem. All right, yes, you're noticing dot plots take longer to do than box and whisker plots. I know. I'll do this last one with you, and then you can do the rest on your own. It says the double dot plot below shows the number of songs per album from 2 friends' favorite 13 albums. All right. Which of the following inferences is correct? Okay, so this is not one that's saying not true. This one wants what is true, what is correct. The mean absolute deviation for both sets of data are about 0.3 albums different. And yes, as soon as you read mean absolute deviation, you're like, oh no, this one's going to take the most work of them all. Because, yeah, it just does. I mean, mean, you're going to have to find the mean. So get your calculators ready. We are going to have to get the mean, and then we're going to have to get the mean absolute deviation. All right, so what is our... Oh, wait a minute. This isn't as bad as I thought. This data is symmetric. Oh, thank goodness. So I don't really have to do any work for the mean. I can already look, and I can see the data seems to center here for Rory's data, and that's at 11. So Rory's mean is 11. Thank goodness for symmetric data. Lane's mean seems to center at 12. So yes, her mean is 12. Oh my goodness. So thankful that I didn't waste our time using a calculator when we can already see what the mean is because it's symmetric data. All right, so we need to get the mean absolute deviation. If you forgot, that means how far is each number from the mean, and then add all those distances together, divide by however many numbers we have, and that'll give us the mean absolute deviation. Now remember, 13 albums, so we got 13 dots. Keep that in mind. All right, so these 2 dots here are what? Just 2 away from the mean. So that's 2, but there's 2 of them, so 2 2s. These 3 dots here are each 1 away from the mean, so that's 3 1s. And then these 3 dots here are each 0 away, so that's 3 zeros. Now, 3 times 0 is still 0. So I'm just going to put 1 0 down if that's okay with you. These 3 dots here are only 1 away from the mean, so that's 3 of those 1s. And these 2 dots here are each 2 away, so that's 2 of those 2s. All right, 2 plus 2 is 4, plus 1 is 5, plus 1 is 6, plus 1 is 7, 8, 9, 10, plus 2 is 12, plus 2 is 14. So I'm going to take 14 divided by 13. That's going to be an ugly decimal using my calculator. That's 1.1 something. So yes, I would write this stuff down. I gave you lots of room to the right, so I hope you are writing stuff down. If I'm going too fast, hit pause in the video and catch up. All right, we're going to do the same thing for lane. So remember the mean for lane is 12. So how far are each of these numbers? Well, there's 1 dot that's 2 away. There's 3 dots that are each 1 away. So that's 3 of those 1s. There's 5 dots that are all at the mean. So that's 0 for each of those 5 dots. And 5 times 0 is 0. The next 3 dots are each 1 away. So that's 3 of the 1s. And finally, this dot here at 14 is 2 away from the 12. So that's 2. All right, 2 plus 1 is 3, plus 1 is 4, plus 1 is 5, plus another 1 is 6, 7, 8, plus 2 is 10. So 10 divided by 13 is 0.8. All right, now that I got all that written down, is the mean absolute deviation for both sets of data about 0.3 albums different? 1.1 minus 0.8, that is 0.3. Oh, well, that appears to be the correct answer. But let's double check. What about the range? Is the range for Lane's data 2 more than the range for Rory's data? Rory's range is 1, 2, 3, 4, because 13 minus 9 is 4. Lane's is 14 minus 10. That's also 4. The ranges should be equal. So, no, choice B is wrong. The average, the mean amount of songs on Rory's is 2 less than the mean for Lane's. No, they're only 1 less than, not 2 less than. So, nope, choice C is wrong. Generally speaking, Rory likes albums with more songs than the albums that Lane likes. No, it's opposite. Lane's dots are a little bit further to the right than Rory's. I mean, you can see the mean is a little bit bigger than Rory's. This is trying to say that Rory's is more than Lane's. Well, no, that's not the case at all. It's completely opposite. So yes, it was choice A, the one that actually took the most work. Not that that's always going to be the way it is, but choice A ends up being the correct answer for problem number 4. All right, there's a problem number 5, there's a problem number 6, there's a problem number 7, and there's a problem number 8. These are on your guided notes, and I'm going to have the solutions for those in a separate video because this one's already 29 minutes long. So we'll cut this video off where it is. Thank you for watching. Do the rest of the problems on your own, and we'll see you next time.